Hi everybody, I'm the greatest living inventor, and today we are doing my invention, colony collapse disorder, virtual reality. So let me write it down. Colony collapse disorder, virtual reality. Okay, so it can be in many times you've seen in abbreviation, in initials. So this is a CCD, CCD, and this is VR. Okay, I'm sure you know that VR is virtual reality. Okay, so I'll take off my jacket. Okay, so this is for helping the bees. Okay. Okay, so so we are helping the bees, which of course is important because they pollinate most of what we eat. Okay, so training the outgoing bees to reach non-pesticide flower fields, and testing the incoming bees to see if they are poisoned using a small-sized virtual reality simulator. Okay, the problem. This is pretty long. This is 8 pages. I will read as much as possible and draw as less as possible. The problem is that the poison Imidacloprid, the most widely used insecticide in the world, which is mostly made by Bayer. Okay, so poison. I'm writing this because it's important. It's the real solution is for Bayer and companies like Bayer to stop using this, to stop making this poison. Okay, so poison is the problem, is Imidacloprid, and it's made by Bayer. Okay, so this is the problem. The problem is that poison, Imidacloprid, the most widely used insecticide in the world, which is mostly made by Bayer, destroys the bees' ability to navigate. So the bees are able to get to the poison, but they cannot get back. So what happens in colony collapse disorder is that the bees get lost or disappear and die from the poison, while the bees that stayed in the hive die from starvation. But even if they could come back, we don't want the poisoned bees to come back inside the hive, because then they will feed poison to the young ones and the queen. Okay, so now the solution, bees virtual reality simulator. Okay, so we put the actual bees inside a box, which is a virtual reality simulator. We are used to humans, people using virtual reality, but now we are talking about bees that use virtual reality. First of all, of course it's not with goggles, I will explain how. First of all, putting bees into virtual reality has been done already by the Free University of Berlin, although in another context. Honeybees enter virtual reality so scientists can study their brains. And I'll give you the link, all the links I'll give you in the description of the video. Another occasion, learning and its neural correlates in a virtual environment for honeybees. Okay, also they put virtual reality, they put bees in virtual reality. My solution has two components. On the one hand, helping the bees not to reach the poison in the first place. And on the other hand, if a bee somehow got to the poison, then to prevent the bee from getting into the hive. Okay? Currently a beehive has a single entrance, which is also the single exit. Okay, so if we have the beehive, let's draw it like this. Hive. And it's got a single exit and entrance. Okay, this is the entrance or the exit. And we put this here. Okay, so the simulator is coming in the entrance or the exit. It's both the exit and the entrance. I suggest we attach to this entrance a virtual reality system for bees, which will basically be something the size of a shoebox, only cubed. Okay, cube. This will be the chamber where the bees experience the virtual reality ride. If we wanted only visual effects for the bees, we would make each of the inner walls of the system a monitor screen. But we also want the bee to be able to freely move, fly in 3D inside the simulator, just like we want people to freely walk in 2D, forward, backward, left and right inside a human virtual reality simulator. So bees have all this plus the third dimension up and down. Okay, 3 dimensions. And for humans we use the omnidirectional treadmill. For humans we use omnidirectional we use omnidirectional treadmill. And for bees we'll use what I will describe here, my invention. So the equivalent of this for bees will be walls with electric fans. Okay, so on each wall there are fans. On each wall and on the ceiling and on the floor of the box. On each wall there will be electric fans, something like the fan in a desktop computer at home. So each wall will be able to push the bee as if the bee is flying into a wall of wind. The bee will feel itself flying through the air and progressing in that direction, while in fact the bee is really flying in the same place, just like a person walking on a treadmill. If we wanted only haptic effects, haptic means touching or feeling with the touch. If we only want haptic effects for the bee, we would make each of the inner walls of the system a wall of fence. But we want both. We want the bee to see, visual, and feel, haptic, that it is moving. How do we do that? For this we use the fact that bees are not sharp-eyed. They don't see well. For example, the bee orchid flower. And I'm giving you a link in the description to Ophrys. It's an orchid that fools bees. Ophrys. So we use a trick from the 18th century of horror theater, Phantasmagoria. Okay, Phantasmagoria. I'm giving you all the links in the description. Where they used magic lantern projection on smoke of scary demons. We also use rare projection effect, but instead, okay, rare projection. We also use rare projection effect, but instead of on smoke or sheet, S-H-E-E-T, we will use a mesh like a mosquito net. This will allow the wind current from the fence outside the chamber to reach the bee inside the chamber. Okay, so here if we take one wall, okay, then one wall will look like this. It has a structure of a mesh, okay, like a net. And on this we do a projection. Projector. Okay, this is the kind of rare projector. Rare projector. And it projects on this mesh. This is like the screen. The bee sees through the holes what is projected. And also there are fans. So this is the haptic part, this is the visual, and this is the haptic. We also use rare projection effect, but instead of on smoke or sheet, we will use a mesh like a mosquito net. This will allow the wind current from the fence outside the chamber to reach the bee inside the chamber. This will also allow the images from the small projector outside the chamber to reach the bee inside the chamber. Behind each wall of the chamber there are one projector and let's say 4 fans. Okay, so there I drew 2, but there are 4. And this happens in this wall, in this wall, in this wall, in this wall, in the back wall and in the front wall. We want 4 of the walls of the chamber to be on hinges, so they can open as doors. Okay, so here there is a hinge. so this can turn. Okay, so it's like the wall of the hive, or the wall of this opens up, and 4 of the sides are on hinges. Okay, so we have I'll describe them and write them. We want 4 of the walls of the chamber to be on hinges so that they can open like doors. The first wall that we need to act like a door is the one closest to the hive entrance or exit. To this door we want an incoming bee into the hive after it passed the simulator. The simulator with the fence rotating in reverse. Okay, don't understand what I meant, but anyway, this is a wall to the hive. Okay, so this is to hive, because we put this here. The second wall that needs to act like a door is, oh, I understand what I meant with the reverse. We just, instead of sucking the bee in, we push with this fence the bee into the hive if it succeeded in the simulator and came back. The second wall that needs to act like a door is the one furthest from the hive, from the hive's entrance or exit. Through this door we let an outbound bee out to the field after it passed the simulator. Okay, so this is to real world. Or to the field. The third wall that needs to act like a door is the floor. The floor, which will have a jar with honey or something that the bees really like. Okay, so here we have honey. Okay, so this is to reward. This is the reward. The jar needs to close right after the bee finishes and flies home. The fourth wall that needs to act like a door is the ceiling, which will be like a death door for a bee that failed in the simulator and it is thus presumed to be poisoned. The fence blow it into a trap where it dies. Okay, so here is to death. Another component that we need in the simulator is an ultraviolet UV flashlight, because bees see, so I will draw it. So another component is the ultraviolet. I don't have room to draw it here, but UV. Okay, ultraviolet. Flashlight. Can you see the colors? Yep. And another component that we need in the simulator, I'm just looking at the time, 19 minutes, okay. Another component that we need in the simulator is an ultraviolet UV flashlight, because bees can see ultraviolet light and they navigate by the sun, which looks like a UV flashlight to them. Here I give you a link to Blacklight. Okay. Blacklight. Okay. This needs to move along the walls, so we need either one UV flashlight on one robotic arm, or cheaper solution will be one UV flashlight on each wall of the cube, so we need 6 UV flashlight. Each UV flashlight will be mounted on a XY rails like a CNC machine or a 3D printer. Okay, so you know how it looks like in a CNC machine. There is like a rail and a rail, and this flashlight is attached, and this can go up and down, this can go left and right, and it can reach any point. So we can move the sun from the bee's perspective. We move the sun to anywhere that we want. On XY rails, like in a CNC machine or a 3D printer. So the computer tracks where the insect is moving through the camera and activates in any given time only one of the flashlights. Or I think a cheaper option will be one static flashlight with optical fibers that leads it to the XY rails. Okay, so instead of putting another flashlight, we can attach this with an optic cable that is like a pipe for the light. Okay, so it lets the ultraviolet light move in the cable to where we want. So this is optical fiber. We need also a mechanism to choose. Sorry, I'm reading again. So the computer tracks where the insect is moving through a camera and activates in any given time only one of the flashlights. Or I think a cheaper option will be one static flashlight with optical fibers that leads it to the XY rails. We need also a mechanism to choose which of the 6 fibers is the one UV flashlight connected to. So we have one like this and 6 fibers, and we need the switching mechanism to choose which cable the flashlight is connected to. We can take a small electric motor like Lego motor that can rotate a Lego axle. Then we place the flashlight in front of the motor so that when it lights, the light goes along the axle. Now we position a tiny mirror in 45 degrees, half towards the flashlight and half sideways towards a direction perpendicular to the axle, and then we position the 6 fibers around the around the mirror, so that when the light from the flashlight can reach a fiber, if the motor, so the light, and then we position the 6 fibers around the mirror so that when the light from the flashlight can reach a fiber, if the motor rotated the mirror to that fiber. Okay, so in general we have, let's say you are the motor, and you have, this is the end of the motor, and this is also the direction of the beam. So you are the beam, like the ultraviolet comes from you to here. Okay, so this is full of light, ultraviolet light. And here there are 6 sorry, didn't okay, 6 optical cables. And there is a mirror, like that rotates towards which the axis rotates and chooses which one of the optic cables will get the light. So if for example it rotates to here, then this one gets the light. If it rotates to here, then this one gets the light. So it makes it cheaper. So I'm putting a link to optical fiber. Another option to control them, which I'm sure is a lot simpler, is with electronics. And unfortunately, I don't know anything about electronics. It's like we choose which of the 7 segment display to activate, but here it's a 6 segments, and we only need to activate 1 segment at any time. So I'm putting a link to 7 segment display. Drinking something, 25 minutes, okay. So when the doors open, there is a short time of stress for the bee, because it might be that the sun disappeared. But after a few seconds, okay, the bee thinks that the sun disappeared, but after a few seconds, something very exciting is happening. Entrance or exit or reward or death. So I hope the bee is like humans and it will concentrate on the exciting thing. Of course, in the death door case, the stress will not happily resolve, but this option is a rare and necessary evil to save the rest of the colony. Another element that we need in the simulator are breadcrumbs. Okay, breadcrumbs. Okay, like in Hansel and Gretel, fairy tale, which will hint the bee in the right direction of the good flowers field. Again, we need this behind every wall of the cube. Okay, so the breadcrumbs are actually particles of scent, like a scent of a flower, that we put here from some container that has this scent, and we open it or close it, and behind this wall, for example, and then it flies to the bee and attracts it in this direction. Afterwards, we tempt the bee to another direction, and so on. So this is a flower scent. So this is the breadcrumbs. Okay, this is the breadcrumbs. Again, we need this behind every wall of the cube. This will be the nozzle of a spray can of a small, of a smell similar to the flower's nectar as possible. It can even simply be fresh flowers that we grounded into a powder. Like with the fiber optics, we can use a system of valves and one pump. Okay, so like this we can use the sunflower one source and the choosing mechanism. This is also similar to Lego, in this case the pneumatic air pressure Lego. My dad bought me this one when I was a child. So I'm putting you links to Lego Pneumatics, first generation pneumatic excavator from 1984, and I'm putting a link in Wikipedia to this model. And it's super cool. So in the same way that the combination of valves can use the same one pump to either extend this extension or that extension, or contract this extension or that extension, we can switch between the tubes to reach the desired end nozzle. Okay, so this is like a spray can that we have connected through tubes to whichever wall that we want, or ceiling or floor, to the desired end nozzle. You can see how one valve works in this video, Lego pneumatic experiments by the Technic gear Lego reviews. But when you connect a few valves, you can control more outputs with one input pump. Or instead of all of this, we could use a rotating nozzle like the mirror in my first suggestion was rotating, and instead of a flashlight we have the spray of flowers. Okay, so either this or that. Now recording the correct ride and a little around that path using drones. Okay, so I'm erasing this. Okay, so now we look from the top, like a bird's eye view. We have the hive. And we have the box. And the box has a door. Okay, this is let's say this is the door. The whole wall is the door, but let's say this is the door. And the simulator. And this is a hive. And here we have a field of good flowers. And here we have a field of bad flowers. Okay, this is poison and this is like good, clean. Okay, and the bee needs to get to the clean and not to the poison. Can you see anything? No. I will use another color for this, or another marker. Sorry. Okay, they look the same, so I'm drawing it the same, but we know that they are poison. Okay. Now, can you see it? No. So I'll use another color. Okay, so this is better. Sort of. Okay, so you can see that what's written here is poison. Okay? No, you can't see anything. I want to close the lights outside, maybe it will help. Does this help? No. So I'm drawing them in black, okay, or in brown. Poison, okay, I'm sure you can see this, just checking. Yeah. Okay, so we want the bees to go here and not to here. Recording the correct ride and a little around the path using drones. Okay, so we use drones. And they record with the camera. And they record the video camera. And this is a drone. And the drones record the movie for us, what we will put in the simulator. The frames. We take the movie and we cut it into many frames that the simulator gives the bee according to where it is. Okay, the drones goes through every possible place, every possible point in the area. Okay, now we need to use the ability of bees to share knowledge with each other in the form of Waggle dance. Okay, so the bees The bees have waggle dance. Which means they like rotate and communicate to their friends, the other bees, how to get to here. You can see in Wikipedia waggle dance. So ideally we can train one bee and reach this bee and teach this bee the directions from the beehive to the good field of organic flowers which have no poison. Okay, so let's write this is organic. So first we use drones to make a video of the path in all the directions that a bee can look. Right, left, forward, backward, up and down. It's like what Google Maps do in Street View, that they film the streets, but also on the axis of up and down. For the up-down, I think we can use one high flyby and another low flyby on the same coordinates and interpolate between these with the computer. But in case this complicates things, then we can forget the up-down axis. It's negligible. Okay, so we feed all the frames of the video into the computer. So if the bee inside the simulator is in a specific in a quote unquote in a specific coordinate, the computer can project the right image on the 6 walls around the bee. Of course, for showing the bee the way in the other direction, okay, coming back, we don't need to record the film again. It will just play backwards because the bee will be in the coordinates in the opposite order. Okay, training the first bee to use the right path. Now we take the first bee when it wants to get out of the beehive. It doesn't get out to reality. Instead, it gets into our simulator. So we tempt it with sense to go to the virtual good path, and when it reaches the virtual good field location, we reward it with the honey, which is the ultimate prize. Now remember the door from the bottom. Now after the bee memorized the way to the virtual field and drank its full, we let it return to the beehive, which is just the same virtual way in reverse. When it reaches the virtual hive, we open the door to the real beehive, and this first bee teaches its friends that there is tasty treats and teaches them the virtual path, which is also the right path in reality. Okay, so it does the dance and it teaches everybody in the hive how to get to the real good place. Of course, we can map with drones a few fields in the area and teach the bees a few alternatives. Okay, now entry password. Entry password. So ideally without our simulator, the first bee exits the hive, finds a good field and drink nectar, then the bee comes back to the hive and teaches its friends through dance how to get to the good field. But the problem is that the good field is not the closest to the hive. So the bees get opportunistic on the way or get tempted on the way to try out the poisonous field. So the first thing we do is set a password to get back into the beehive. The password is not verbal, it's navigational. Let's say, for example, when the bee exits the hive, it must go in the simulator 100 meters to the north, then 50 meters to the east. When the bee comes back to the hive, this is of course flipped. 50 meters to the west and 100 meters to the south. We teach this, okay, we get to the same place back. We teach this to the first bee before it gets out of the hive. So from the bee's viewpoint, this is just a part of the path. But for us, this is the secret part to know when the bee is back, whether the bee was poisoned on the way, because then it will not know how to do this password part, and then we take that poisoned bee to the trap behind the death door and save all the other bees at the hive, the queen and the young ones, from poisoning. Okay, summary of the process. 1. Record good path with drone. 2. Connect simulator to beehive, possibly at night. 3. Teach first outgoing bee the password and the virtual good path. 4. Return the first incoming bee, the same bee from step 3, through the virtual good path and the password, still reinforcing memory, not testing password yet. 5. Now switch the simulator from learning mode to only password mode. 6. Meanwhile, the first bee taught its friends the good path and password. Okay, did the dance. 7. The next outgoing bee does the password and gets to the real world good field. This is real now. This bee is rewarded with real good nectar. 9. This bee returns to the beehive, which is the entry to the simulator. If it passed the password successfully, it teaches more bees, and we go to step 7. 10. In the following day, we no longer need the simulator because all the bees know how to get to the real world good field. Okay, so they only need the simulator once in a while, or after they get tempted to the poison, or after a certain portion of the bees get poisoned. Okay, so I'm just a final remark. Economic feasibility. Since this machine is needed only in the beginning flights, it doesn't make sense for each beekeeper to buy a machine on his own. After 1 day of training, the bees are happy until the good fields is depleted. So one machine can be shared by multiple beekeepers, each with multiple beehives. So the body which buys the machine and the drone should be the central organization that the beekeepers are affiliated to, such as the American Beekeeping Federation or British Beekeeper Association and so on. This body will rent the machine to the farmers in low prices or even for free, because it's also in the body's interest that the honeybees will flourish. And it goes without saying that since it's a human survival issue, the world governments and international organizations must subsidize and help as well. Okay, so this was my invention. I hope it was clear. And I will see you in my next invention. So thank you very much. Goodbye.